Hey, hello there. Today's Leetcode challenge question is called the two-city scheduling. We have 2 people the company is planning to interview. There are 2 cities that the company has office that are open to interviews. So we want to do some kind of a balancing to send only half of the people to city A, half of the people to city B. There are certain costs involved in flying the people to either one of those cities. The cost information are stored in an array. It's an array of size 2n. Well, each element is a tuple of two things, be the price to fly the person to city A and the price to fly the person to city B. So we want to find the minimum cost to fly for the ideal partition about this 2n people into two halves, such that the total cost is minimized. So looking at some really simple example, I guess the simplest is just the 2 people. So we have, let's look at this particular one. We have 2 people. For person 1, it takes $10 to go to A, 20 to go to B. For the second person, it takes $200 to go to A and $210 to go to B. So for this particular case, if we just try the 2 options, the total is always going to be, if we choose the person A to the first city, that's 10 plus 210, or the other way around, it will be 20 plus 200. The total is the same. So that means it doesn't matter which city we send person 1 to. And for the reason is that the difference is actually the same if you subtract the price difference for each person. If we use the latter one to subtract the first element, the difference is 10. So since the difference is the same, there is no difference which city we send this 2 person to. So this tells us, this simple example tells us the price, individual price, does not matter. All that matters is the difference between these 2 prices. So let's look at some little bit longer example. Maybe something like this. So we have a slightly larger candidate pool. They have 4 people. If we do the sum to take the difference, 10, 20, 30, and 40, we would want to do, the thing that we would want to do is to put the latter 2 to city A, so that we incur $70 of savings compared to if we fly those 2 people to city B. For the first 2 people, we want to fly those to city B. Even though individually looking, we send the first person to city A actually save money, but globally, as a whole, this would only cost $30 more. But if we choose any one of those people to fly to city B, the cost is larger. So looking at this, we can see if we sort by the difference, we can just chop the array, sorted array into 2 halves, and send the first half to one of the cities that saves the most, and send the other half of people to the other city. So just eyeballing this, if we actually do a swap, so the optimal here is that 20 plus 30 plus 10 plus 10. So let's say that we swap the middle 2 people. The cost will become 20 plus 40 plus 10 plus 10. So it will be 10 more than if we don't swap. So the reason being that since that the difference here are sorted, if we do a swap, the cost is going to be increased by the difference here. So you notice the 30 subtract by 20, that's exactly the difference here between the 30 and 40s. So just looking at this 2 example, we see we just need to sort the costs by the difference, and then take first half to go to city B and the second half to go to city A, and add all those prices together, and that would be our total minimum. We sort of sketched a little bit, not really proof, but showed that if we do one of the swap, we will end up with something that's more expensive. So for this, we need to sort. So the time complexity is n log n, and the space depends on whether we do in-place sort or not. If we're allowed to do in-place sort, it will be constant. So that's the time and space. Otherwise, we'll just make a copy of this cost. So it's a linear in space if we make a copy instead of a in-place sorting. So yeah, so that's pretty much the analysis. Let's code this. So we're just going to sort by the difference, have the CDB's price subtracted by the CDA's price. Since that we're looking at the savings to, so this difference is telling us that the savings we can have by flying the person to CDA. The stuff on the left is going to be less saving if we sort in the ascending order if we send them to CDA. So as a result, we would want to send them to CDB. For the second half, you will have greater savings if we send the person to CDA. So for that reason, we send the second half to CDA. Total is 0 in the beginning, and we're just going to enumerate over the new costs. Putting for the first half, we're gonna just looking at the price for B and add those up. For the second half, we add the first elements. So should I include this? Oh, less than. It should be less than. If we have 4, divided by 2 is 2. So this starting with 0, so it's 0 and 1. So it's strictly smaller than. Yeah, so let's put this onto one line, I guess. Okay. Yeah, so this is the code. Yeah, we sort by the relatively savings. And just iterate over the sorted array one more time to collect the total number. Yeah, so that's this question today.